So let's get to it. And it's part 1, and it says main effects. And what I'm going to try to do is just pick out the important things, primarily because every single one of you know how to do main effects. You're going to go back and reread this module and go slow, but you're going to see I'm going to be like, oh yeah, you know how to do that. You know how to do that. The reason I'm going to do that style, like there's the thing, you know how to do it. There's the thing, you know how to do it, is because the next module, you don't know how to do. But the next module is a lot easier to understand if you reminded yourself you know how to do main effects. Everybody with me? And that's like really its purpose. Does that make sense? Yeah, so I'm just reminding you know how to do main effects. And then there's one more thing I want to say to Matt's point from earlier today, because him and Billy were in this really cool conversation. There is a, first of all, and this is not provocative or anything, this is like factual, if you will. Every single, and I'm looking at Easton, one of our PhD students, to see if he raises his eyebrows. Every single causal effect that's ever been estimated or tested for in a randomized trial, 99%, let's not say every, are marginal effects. They are main effects. Okay? So like the effect of B mod versus med is a main effect. It's an on average effect. Having the number for a main effect and then looking at moderators and having those numbers does not mean any assumptions were made for the main effect. So in other words, when I focus on a main effect, it does not mean categorically, there's no doubt in my mind, y'all, having focus on a main effect does not mean I made any assumptions that there were no moderators. That is a falsehood, and it's somehow gotten stuck in certain hemispheres of our training. So I can have a main effect in one hand, and it's valid, and I can have all the moderators of those two things I compared in that main effect, and those are valid and did not invalidate the main effect. I need y'all to understand that concept, because a lot of the times when we talk about interaction terms, people say, oh, if you ignored the interaction term, then the main effect must have been wrong. No, it's not. Billy.
But Danny, there's an issue that I think was brought earlier, that sometimes there are interactions that actually undermine the main effects.
Yeah.
But if that is the case, it means that you're not supposed to size the trial for the main effect. It means that you need to size the trial for the interaction. Because if you anticipate a very strong interaction that makes your main effect 0, that means that you cannot plan the trial to detect a main effect.
No, it doesn't mean that you cannot size the trial for the main effect. It means you're not going to want to make that your primary aim.
Exactly.
But what I said still stands. That main effect, be it 0, is valid. It is a main effect that is 0. It's valid, it's real, and the moderators of the interaction terms are also real and valid. And that concept is going to rear its head in this module, but it's one that like got the field in trouble a long time ago when there were scholars that, you know, if you didn't put an interaction term, it meant that you thought the interaction term was 0. That's not true. That's a falsehood. It just means I'm not focusing on the interaction term at this moment, meaning I have a causal effect that's an average treatment effect, if you will. Does that make sense? So I'm just trying to square up some of the conversations, okay? And you're going to see that rear its head. And that is actually true in every trial ever designed by mankind, including optimization trials, which is the focus of, well, including SMARTS, which is one type of optimization trial, all right? And I'm happy to keep talking about that, okay? All right, about that concept. And you're going to see it rear its head. So what am I going to do really fast? I'm going to define 2 of the common types of primary aims in a SMART, formulate a specific primary aim, explain key stats considerations, and interpret results. all of this, you're going to know how to do because that very first primary aim in a SMART that we showed you, compare the main effect of initial intervention. Everyone in this room already knows how to analyze it. So I can like bang through that super fast. You'll see. Okay? And actually, everyone in this room knows how to do this one too. And by the way, these effects are captured inside of that one. I just chose not to focus on them. That's the point I'm making. Okay? All right, so let's get to it. Oh, there's going to be SAS code. Don't worry, especially if you're not a SAS user. It doesn't matter. I'm just using the SAS code as like, this is what the code looks like to kind of point at things you might do when you're coding in whatever your favorite language is. It's irrelevant that I'm using SAS. Does that make sense? Like you guys can use SPSS, Data R. We just had to choose one to show you code. Okay? All right, so illustrative example. So every single one of you know this like inside and out. And by the way, the actual study, remember, was measuring response status every month starting at week 8. But sometimes in these 3 days, we just pretend like it was at one spot just because it simplifies things. All right, everybody with me? All right. So I'm clicking through this because if I go through that one more time, you're gonna be very upset with me. All right, so I'm gonna click through this too. Everybody raise your hand if you know all the embedded adaptive interventions in this SMART, or if you want me to go over them again, right? There's the blue one, start with med, augment. There's the other blue one, start with BMOD, augment. There's this other one, start with med, intensify. And there's this BMOD, intensify. One thing you noticed immediately is that every single one of those embedded adaptive interventions has 2 pathways. Has that confused anyone so far? Because that's crux to this. Like, I need y'all to realize that an adaptive intervention is for the entire population of kids here. So an adaptive intervention is not like I've heard scholars before say, oh, the adaptive part. No. The whole thing, this whole thing, D and F, this whole thing is the adaptive intervention, right? When you talk about an adaptive intervention, because it's something you plan to do with all the kids, it's something you do with the responders and the non-responders. And you see it in the way we're highlighting. Everybody with me? That's part of the coolness about it. All right? Are we good? All right. We pretend for the majority of today's talk that everything is 50-50, but just so you realize, we're not saying you must do a SMART that's 50-50 at every randomization, okay? Okay, but that's just how we're cooking it up to make it simple. And most of you will do 50-50, all right? Although I gotta say, education scientists are among the people who have the best justified reasons for not using 50-50. You guys have good papers on that. You do. And a lot of it has to do with the fact that you guys sometimes your interventions are costly and you want to make it a 30-70 because you don't have enough money and you guys are thoughtful about those things, okay? I work in other communities that aren't as thoughtful, but yeah. Yeah, because there's equipoise, because there's complete equipoise between if you put aside the cost and those other things that you guys usually bring to the table in education, we sincerely want to know, this is neck and neck and we have complete equipoise and we want to know what's the effect of augment versus intensify and BMOD. And of course, we all know that at the 50, we get the maximum power. So it's kind of like a combination of those two things. Of course, putting cost aside, right? I'm putting cost aside. Like the old Rodenbush papers, he helped us understand those ideas then. Okay, thanks, B. All right, so this is the first time we show you what the data looks like. Now remember, y'all, I'm going to say this a couple more times. The purpose of today is not to teach you the stats and force these things and scare you. It's because when you write a grant, there's going to be a stats section. And whether you are writing it or your analyst is writing it or you're collaborating, which would be a ideal thing to write it, you just got to kind of have an intuition about it. And that's all we're doing today is getting some intuition. So this is the first time you see what a data set might look like. So let's take a look, right? So this is all fake data, by the way, okay? I'm never showing Bill's data. So oppositional defiant disorder is some covariate at baseline. Does the kiddo have oppositional defiant disorder? Another covariate at baseline was the kid's ADHD severity. And did the kid have prior med use, right? Because some kids enter studies or enter treatment having already had prior med use, right? That's common in ADHD. And then race. And then you have your stage 1 option, right? And one of the things we're doing so that we don't get stuck on the thing I spoke about earlier where we think that the main effect is invalid because I didn't put an interaction term in the model, is we're going to use -1,1 coding. This makes it overtly explicit, that concept. One of the reasons we got stuck in those spaces is because we used to use 1,0 coding. And when you use 1,0 coding, the little beta next to your A1 has an entirely different meaning when you throw the interaction term in there. But now, you'll see the little beta next to the A1, whether or not I throw the interaction terms in there, I'm golden. You'll see. You'll see. Okay? But let me show you the rest of the data, because this only has A1. I have response status. And in the Pelham study, I have the time until now in response. We're going to come back to that, because that's kind of a cool thing that happened in Pelham study, right? Right? The month at which the kiddo non-responded. There it is. Why is there an NA there? Anybody tell me? Why is there an NA there? Do I need to impute that? What is it? Because they're a responder. Do I need to impute that? Like, do I need to deal with that statistically? No. No. This variable doesn't make sense if you're a responder, right? Yeah, so this is okay. Don't get sad that there's missing data there. There might be other missing data on other covariates that you'll want to impute, but not that one, right? Okay, all right, don't be sad. And then, of course, we have adherence. Adherence is adherence to A1, right? Adherence came after A1, right? It's adherence to, I don't have space, but it's adherence to stage 1 intervention, right? And then there's A2. Are we sad that there's an NA there? Why? Why aren't we sad? Like, oh my God, the trial failed. Everything went wrong. Huh? Yeah, because responders didn't get randomized. So the only time you're going to see a 1 and a -1 for A2 is for zeros here, by design. So when you're done with this, when you're analyzing data from a SMART, you're going to see NAs all over the place, potentially, and you're not going to necessarily freak out and think, oh my gosh, my statistician has to impute it, right? Like, this is all by design. So like, if I really wanted to be careful, I would put NABD, by design, right? And then other NAs I do need to impute, right? Everybody with me? Okay. Will you ever, in a SMART, have an NA without the BD for someone who's a non-responder? Will you ever have a missing data for someone who's not a responder? Like here on this picture, I have complete data. Every time I see a 0, I see a value for the A2. Will you have? Can that happen? What do y'all think? Jessica, you think so? If they drop out. That's interesting. Yep. If they drop out of the study, right? What else? But if they drop out of the study, let's go, you know what? I'm not going to get caught up with that, but what I wanted to tell you, the point I wanted to make, is if you think about everything that went down yesterday, there's 3 variables that should never be missing, even in the face of dropout. So this is going to be like a little bit of like a like Jedi mind trick. A1 will never be missing. R will never be missing. Because remember our conversation yesterday? You know response status if they don't even show up. Remember that? Because you have to have a plan. And believe it or not, even A2 will never be missing. So yes, they might have dropped out before the A2 coin was flipped, but I could have still flipped it, right? So yeah, A2 is a little tricky. It could be missing if you dropped out of the study. It definitely is not missing if you dropped out of treatment. Definitely not missing. Okay, And then there's school performance. All right, so I'm just orienting you. I went slow here, and then hopefully I can go a little bit faster. All right, that's what data looks like in a SMART. Yeah?
Do you randomize to stage 2 before starting the trial?
You can. You can. The sequential, and listen to what I'm saying, the sequential randomization table matrix could all be set up ahead of time. But I want you to, and we don't have a module on this, and we should. Right, Billy? We should. But I need y'all to realize something. Notice what I just said, because it was subtle and nuanced. The sequential randomization matrix table could all be known ahead of time and in a drawer. But, let me look for my design. And Billy and I don't know where we talk about this. Maybe I went to the bathroom or something, and maybe we don't have a module on it. You're gonna almost always, 99% of the time, have stratification variables at all of these, right? But you do not know the value of the stratification variable. So like among non-responders, you might be stratifying on like whether or not they adhered, right? You following me? But you don't know the value of whether or not they adhered. So that's the nuance. That whole randomization matrix is known ahead of time. Like you literally have like mapped it all out for if Danny would have become adherent. You know what I mean? It's a monster, right? Are you following me? But yes, over here before the trial ever started, you can have everything laid out. And I know some people that do it that way. And then I know some people that do it in real time. There's pros and cons. If you do it ahead of time and you put it in a drawer, hopefully only one human knows where that drawer is, right? Right? You know, because the moment somebody finds out what Danny's going to get randomized to, well, there goes the entire sequential design, right? All of a sudden, these two randomizations all showed up here. You follow me? The moment that happens, there goes the SMART out the window. Immediately out the window. You don't have a SMART. There's no sequential randomization. And that'll bite you in the you-know-where. When we get to Module 7, you'll see why that nips you right there. That's a major problem, because what it means is that non-responders were not the same up to week 8. In other words, having the expectation that I know, knowledge that I know, right? Any of your teachers, if they know what's happening later, then all of a sudden somebody might be cherry picking, you know what I mean? Basically what's happening is you're anticipating the thing you're going to get. And therefore, you look at your data and you realize, oh, my non-responders have the same mean across every covariate that came up to this point. That's how you know something fishy went down. You know what I mean? And that will happen if somebody looks in the drawer. Yes, Billy?
So one example here is think about a child or family. And suppose that they were randomized to the medication, but they know that if they become non-responders, you're going to augment with more medication.
Yeah.
They actually want more medication.
Yeah.
They want medication not just at school, they also want medication at home.
Yeah.
That's how this trial design was set up.
Yeah.
Adding more medication, meaning adding more medication in the after school hours.
Yeah.
So they want this, so what's going to happen? What are you going to see? You're going to see kids, families becoming non-responders sooner because they know what you're going to give them subsequently.
Yeah, that could happen.
That makes the comparison between medication and BMOD initially, it makes it confounded.
Yeah.
With whether or not the child in the family knew, because some knew, some didn't know. If the second stage assignment is not fully blinded, that's the issue. If it's fully blinded, the kids, the families, the staff, everybody, you're golden.
You're golden. Yeah. And the other thing that makes us realize, wow, now I'm really off topic, but this is a delicious conversation, right? Actually more fun than Module 4, Billy. A lot more fun. The only, you know how we've been talking about optimization trials and evaluation trials? You guys know how we've been doing that? And how like the purpose of an optimization trial is to walk out with an adaptive intervention in your hand that you either go into the field with or go into an evaluation trial with. Remember that concept? The only effect mechanism that is never going to be part of a SMART is the expectancy effect mechanism. And I am not saying that is small, by no means. But the expectancy effect is being controlled in a SMART. In other words, like in a SMART, we don't know what the non-responders are going to get because we're studying that. But after the SMART and you have the adaptive intervention in your hand, that thing is in your hand. I can write it down. I know what non-responders are going to get. So when you go to the evaluation trial, don't fool yourself into thinking you're going to get, even if everything went perfect, the most like million sample size, massive integrity in all your scientists. Everything's perfect. You are not going to get the same effect in the evaluation trial because the evaluation trial will have the expectancy effect. And I'm not saying that's small. And I don't have a problem with that. I really don't. All randomized trials that are evaluation trials have expectancy effects. We control that in a SMART. We want to control it, but it's the only one that is not at play here. You got it? If you wanted an expectancy effect, then you will have to tell people what they're going to get in stage 2 up here so they can have the expectancy effect. But then it's not a SMART. So then it messes up your AIM type 4. So this is a very subtle conversation we're having, but really important. Yeah?
So related to that, the consent forms for teachers, for example.
Yeah.
Depending on the IRB members, they may force you to include what you're going to do.
Oh, you have to. Right? The consent form is the only time that I recommend. Man, now this really needs to be a module because now we're getting off track. The consent form is the only time, if I'm designing the study, that the families, the teachers, that everyone knows what's going to happen. They need to because that's ethics. They must. But please don't you dare consent here and then reconsent there. You just killed your study. You just, disaster. There it goes out the window. Consent is not a randomization procedure. Consent is a study procedure. Okay? Wow, now we're really off topic, but these things I guess are really important. Yes, sir?
A small question. We were talking about it at our table. If you get imperfect randomization at the first stage, could you compound that imperfection at randomizations at second and third stages? Does that come up or things you've thought about as you go through this?
Well, those two coin flips are independent of each other. So I think on that point, you guys all have the tools in your journals because I know education scientists are really into this idea. Like, you can do whatever fancy technique you want to protect yourself against chance imbalances, like whatever it is you like, propensity scores, covariate adjustment, and you're going to be okay. And the only catch is, and I'll get to this over the next few days, today and tomorrow, is you can't do covariate adjustment for anything that happens in here. I'll get to that. So you'll have to do a weighting approach. But other than that, I think you're going to be golden. So yeah, it's supposed to be 50-50, but you got whatever. It just so happened that kids that were slightly sicker ended up on BMOD. You're going to be good using all the tools you guys already have. And we've written the papers on that, and you guys are really good in education about that kind of stuff. I know you guys have write a lot of papers about it. So you're good. You're good. Okay. All right. I'm behind, but I'm having fun, so I hope you're having fun. Okay. You'll see why I can bang through this, and I won't delay, Greg. I promise you. I promise. So I stop at what time, Ian? 11:10. Perfect. Yeah, it's perfect. All right. So AIM type 1 was compare the main effect. So sample formulations is our goal is to give you language. Because, we don't want you flying into Ann Arbor just getting design and stats because, oh my God, you'll die, right? We also want to teach you how to write things and formulate. These are 3 different ways to formulate this primary aim. They're all valid. So to determine, if you were writing a grant, to determine the best first-line treatment in terms of the end-of-study school performance, controlling for future treatment by design. That's a main effect. To determine the effect of starting with BMOD versus starting with MED in terms of end-of-school performance. These are equivalent, they're not equivalent in the way I'm languaging it, but they're equivalent when I go do the thing, and then like the math. To determine whether it's better on average to begin treatment with BMOD or MED in terms of end of school. This is my favorite because this one is just so beautifully crystal clear. There's the main effect right there. I'm using the word average. There's me talking about beginning. There's me talking about the BMOD and the MED, and there's me talking about the outcome. So like personally, this is the one I use, but all of these are legit. And they're all doing the same thing. They're all doing the main effect. Everybody with me? So today and tomorrow, you're going to see me using different language because all of you are going to be writing grants, and I got to give you something to lean on. And this analysis, you know, this is like a funny thing here because nobody does this anymore, right? Like no one does simple two-sample t-tests anymore. But I'm making a point. This analysis is one every single person in this room knows how to do. You compare everybody who got MED to everybody who got BMOD. I don't need to teach this to y'all. This is like, take everybody in these 3 boxes and everybody in these 3 boxes and just look at the mean. I don't, you know what I mean? There's nothing to it. You can stick it in a 2-sample t-test. You can put it in a regression, which I'm going to show you. You guys know the 1,000 ways to do this. You've been doing it. You all were trained on this because you all were trained on 2-arm RCTs. Like there's nothing fancy going on here at all. Okay? You're averaging over subsequent treatments. There's a picture showing what's happening. This is no different from what we do in RCTs, except that in some ways it's better because we actually know what's happening in the interim. You know what I mean? Because it's being controlled by design, which is what we want to do in an optimization trial, maybe not in an evaluation trial, right? In an evaluation trials, you put it in the world and let it go, right? Here, we're trying to make the thing better. But you guys know how to do this, right? Everybody with me? Are we all on the same page? And this effect is legit, and there's nothing wrong with it, regardless of the effect intensify augment had. Regardless of the association between responder status and the outcome, this is legit. This is causal. This is legit. This is a main effect. And there is. Okay? Everybody with me? In the early years, this is starting to get understood. Like in the early years, we would have 20 or 15 years ago, we would get stuck on this slide. People just didn't want to think about main effects in the early years. We're not ignoring, we're averaging over. All right, so what does this look like? You guys don't like, I'm sure none of you like 2-sample t-tests. I'm sure some of you, you guys like to do regressions, right? Because all of you guys are trained a la Rodenbush. Most of you are, who was on my PhD thesis committee. And who was your thesis advisor. So like most of us will use regression logic, which is great. So you can run this regression. This is the silly one, the baby regression, right? There's B0. Because I coded A1 as -1,1, and because I used a 50% coin flip, because of those 2 things, beta 0's interpretation is just the average school performance. It's got a meaning. It's the average school performance. It doesn't matter what you set this to. Because I used the -1,1 and because I had 50% randomization, because if you don't have 50% randomization, you can't use -1,1. You have to use something else. So because I used -1,1 and I have 50% randomization, beta 1 is like a test that beta 1 is 0 is a test that this main effect, this mean versus this mean, is 0. But if you want the actual value of that mean versus that mean, you'll have to do 2 times beta 1. That's just because I'm using the 1 and the -1. And you can see my little logic down here, right? I don't need to go over this with you guys. So if I put the mean under BMOD, I stick a 1. If I put the mean under MED, I stick a -1. When you subtract these, poof goes beta 0, and there's 2 beta 1. Okay? So basically, nothing changes. A test of beta 1 equals 0, that null hypothesis, is a test that there is no main effect. Everybody with me? Yeah? It's beautiful. It's easy. And then, of course, Many of you guys will not want to do this. You're going to want to do covariate adjustment. So put covariates to your heart's content. Don't put too many. So to your heart's content within reason, right? Because if I'm using up, the usual thing, y'all. I don't need to teach you guys this. If I put like a gazillion covariates, I might get myself in trouble, right? Because I'm using up degrees of freedom depending on my sample size. But what I like to teach people is put your covariates all in mean-centered. That's a trick Roddenbush drilled down my throat. And if you do that, I can, for all intents and purposes, just ignore them all. And again, beta 0 is the mean school performance. Beta 2, beta 1 is the causal effect. Everybody with me here? Easy peasy lemon squeezy. And in fact, this is going to drive you bananas. But even if I put covariate A1 interaction terms, beta 1 is the main effect of the two means, and beta 0 remains the school performance. Everybody with me? So this is essentially being done in the lens of through the lens that we see the world at D3C and the way statisticians see the world. This part is being done at this point in the conversation for efficiency, right? And or to protect yourself on chance imbalances. And all of you guys know the rules. All of this is pre-specified. Every single one of these X's is pre-specified. You don't want to go fishing, yada, 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 yada. I don't need to teach you guys this. Mason.
In fact, if you have not 50-50 randomization, you should also include the covariate treatment interaction.
Oh, cool.
So this main effect is if we have A1 centered covariate.
Right on.
Only if we have 50-50 randomization.
Right on. All right. So you guys all know how to do this. Why am I doing these slides? Because the next module, if we don't have this in your head, it's going to be hard. All right. But you guys, and there's all of you guys know how to do a regression in SAS, right? Or SPSS or STATA or R, right? There's my regression model. There's my asking for the mean under this, the mean under that, and the difference, right? Okay. Are we good? It's kind of fun, right? It's kind of fun to have a module that feels good. Like, I know what I'm doing. It's great. All right. I'm just going to bang through this. Okay. And then this is a pretend result because one of the things you have in your packet is you guys have access to a fake data set on our website. And so you can go in there and pretend you're analyzing Bill Pelham study. It's all fake. But it's all in there. And if you can't find it in our Katie.space, don't worry about it. We're going to try to alert you to it. But no matter what, in the virtual days, you know how we're having those 2 virtual days when you come back over Zoom? Those virtual days are all about analysis. So we'll make sure you know where those data sets are by then. You feel me? So and you can, to your heart's content, go analyze the fake data. Okay? So this is a pretend analysis. There's nothing fancy here, except that if it were me, I would never report these 2 p-values. Just because I don't want to get people in the bad habit of put p-values everywhere, right? The only p-value that matters here is that one. And this one is showing that there is no evidence of a main effect in this pretend data. Okay? Although we got slightly better to begin with BMOD, because BMOD was coded 1 and MED was coded -1. Okay? Good? Yeah? Feels good? Warm and fuzzy inside? All right? Any questions? Okay. Here's a little side analysis that you might want to do. There's nothing wrong if you want to look to see what the percentage of response rate was. In fact, I think it's very useful to know that. But this will never be a primary aim. Well, I don't recommend this ever be a primary aim for you. Equivalently, I don't recommend that you ever make the school performance at the end of stage 1 a primary aim. Why do y'all think I'm saying that? Why are none of our aim types the very, 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 very proximal effect of MED versus BMOD? Because those have nothing to do with an adaptive intervention. And yet, you have to be interested in adaptive interventions to do a SMART. You know what I mean? So it's just weird. It's just really weird to go through the fuss of designing a SMART and arguing for it and then making your primary aim something that has nothing to do, right? Because up to this point in this study, there's only 2 interventions. So it's just, you know what I mean? That's not to say this is not useful. In fact, this is very useful because this can help you explain this main effect. Of course, right? This is on the pathway. And this could help you explain the comparison of adaptive interventions because it's on the pathway. So to your heart's content, do mechanisms, but don't make it your primary aim. You guys with me? Oh, and so we did the little side analysis and we discovered, oh gee, it looks like the medication people responded. Where's my ADHD people? ADHD. I think you guys see this in all your studies of behavioral versus medication. In the short term, medication kicks butt. Even Bill would constantly say that. He's like, yeah, this is obvious. You know, like if you're looking at ADHD symptoms and you take a medication, you're going to feel pretty good in the short run. It doesn't mean that that's what we should start with. Right? That was like Bill's career right there. That was his career in a nutshell. There's a lot more to his career. Right? So in this fake data, we cooked it so that you saw med have this amazing early response by 7%. All right? Any questions about a main effect analysis? I have 11 minutes left, so I'm doing pretty good, actually. I'm actually not going as fast as I thought I needed to, so this is great. Are we good? Yeah? Fun? It's fun so far? Yeah? Okay. It's hard to make a simple 2-arm analysis fun, but I tried. I tried my best. All right, I'm going to try to make this one fun too. This one also is not simple to make fun because all of you guys know how to do it. But here we go. Here's the languaging. So suppose you decided aim type 2 is your primary aim or whatever. So here's some languaging. To determine whether among children who do not respond to either first-line treatment, that caveat is important, because I am subsetting the population for this primary aim. So I better put the little caveat. All right? Right? So I got to language it. To determine whether among the children who did not respond to either first line, is it better to intensify or augment in terms of end of study school performance? Regardless of history or treatment, controlling for first stage intervention options. So this is nothing more than B and E, because that's the augment that occurred, versus CF. But not with everyone, only with the non-responders. All right, now let me give these people some love, because I've been loving that screen a lot. It's not fair to you guys. I've been giving that screen a lot of love. All right, yeah, you guys, we good? So, you know, by the way, this is an incredibly useful tactic when you're writing grants. And you guys at IES are lucky because Billy and I get like 11 or 12 pages because we're more NIHers, but you guys get like a ton, right? Like 20 something. Yeah. So you guys can really slow down and explain things. And we have to squeeze it in. But you guys, literally this tactic of showing these little letters and telling your reviewer and kind of coaching them. Like for this aim, we combine B and E versus C and F. You know what I mean? That tactic is like key. You know, you'll see like people say, oh, in parentheses, B plus E versus, you know, you got to do that. You got to do that because a lot of people still don't know how smart to analyze. We're still in that process of building the field, right? So you got to coach your reviewers. Does pooling make sense given actual treatments are different? Okay, so this is something that came up yesterday and it's probably still in your head. Like, gee, Danny, this bothers me so much. I'm putting B and E in one bucket and I'm saying that versus C and F. Okay? First, look at my language. Whether do not respond to either first-line treatment. So I'm embedding that concept in my language. I'm not trying to put a veil over anybody's head. I'm not trying to hide anything. You see that? Like some thought went into this, right? Either first-line treatment. If you don't like this kind of aim, don't propose it in your study. But I'm here to just tell you what's possible. This is valid, this is causal, and there's nothing wrong with it. Just like if you don't like the main effect, don't propose it. But it's valid, it's causal. You guys feel me? Like, I'm not suggesting you guys do like an analysis that's not causal. That is, when I say non-causal, that doesn't take advantage of randomizations. Like, for example, like I have seen people say, oh yeah, one of my aims in my SMART is to compare responders and non-responders. There's nothing causal about that, right? I don't randomize to whether you're a responder or non-responder. But all the aim types we are showing you over these 3 days, every single one is one that is causal, that uses the randomizations to what we use randomizations for, to get rid of confounding. Yes?
Quick question. I know you're on a 7-minute timer.
I am, but we're good.
But I just want to check, like, all of this, it's so helpful, but like hard to kind of bring down. And I keep thinking back to, it's very choose your own adventure-y, which is fantastic, but also a little overwhelming. So like at the very beginning when we started like all the introductions and you had, I forget which module it's part of, but there was like a flow chart. And it was like, is this an adaptive intervention? Or do you need an adaptive intervention? Yes? No? And then it brought you here.
Oh yeah, do you need a SMART? The little flow chart for whether or not you need a SMART. Yeah, we flow charted that.
Is there any type of resource that is out there that you have that's like, what type of aim would be better for your question, or deciding between those?
Not that I know of.
Okay.
But I won't be writing that paper because like I need you to do I need the field like to do, I want you, my job as a methodologist is to show you what's possible.
Right.
I want you to do your own thinking because at the end of the day, like, first, I don't want to pigeonhole people into like lack of creativity, lack of innovation, of which there's a lot going on. You know what I mean? And I just don't want to do that. I don't want to weigh in that way. My job is to tell you what's possible in a SMART, and then you have to choose your primary and make your cogent argument to your reviewers for why you want to answer those. And we're trying to give you all the tools so that you can sit down and have that conversation with yourself or your team. But I don't know, Billy, I won't be writing that paper. I won't be. I'm not, in other words, I am not going to weigh in on which of these three to choose and when.
I hear that.
I'm not gonna. It doesn't mean Billy's not gonna, but I'm not gonna. You know?
I hear the point. It's just like kind of, and I love what Billy said, there's no free meals.
There's no
Like,
free
we were
meals.
just talking about that in the last module, and like, okay, I just wish there were like mini versions of you
Yeah.
on our campuses.
Right. Oh, that's so nice.
Open and be like, hey, so talk this through with me. Like,
Yeah.
Anyway,
To be honest, like, it is talking it through with your team. Like, you're going to get people on your team, and there's maybe 10% of you here that do not love AIM type 1 or 2. So don't do it. We're going to show you AIM type 3 in a second, like, after Greg Roberts is up. You know what I mean? But I think when you see all three of those AIM types that we think are candidate primary aims, you get to pick. And maybe, and actually there's more than just 3. Those are like 3 very generalized. It turns out that there's many little mini versions of all 3 of those, depending on whether I have repeated measures, depending on whether it's a clustered SMART. But these are like the core 3, you know, if you will. Actually, an AIM type 3, which we're going to get to later today, has like an A version and a B version. So you'll see, our job is to give you everything, and then you do the thinking. You know what I mean? But we're not like leaving you hanging. We're giving you everything and then telling you like, hey, look at these 3 case studies. We walked you through the logic that was inside all of those PIs. I don't know if you realize that. Go back to what Analyses did. Analyses laid out. I get goosebumps because I freaking love that module. Analyses laid out like, okay, these investigators, this was the background. This was what was going on, and they chose this primary aim. But all of them chose different, wildly different primary aims. That's great. That's what we want. We want you to think. The reviewers want you to think too. You know? The reviewers want you to think. And guess what? If you don't think, they come down with their hammers. They think for you. And that's when you don't get your grant. You know what I mean? Like if you don't have an argument that can hold itself, that's when you don't get the grant. Because they come in with their hammers. Well, what about What about, you didn't think about, you know what I mean? Right? Like everyone has a hammer, yeah.
So I think, I'm always wondering if like some examples of aims pages would be helpful, because I think your wording of how to set up the aim is really helpful.
Yeah.
But I'm really interested in like this like manufacturing the second stage, but trying to figure out how to crouch that in terms of like, well, we have other first randomization first that we're also looking
You'll
at.
see.
Okay.
You're going to see, and that's all going to come together. Right. If you don't see it yet, just be patient. It'll all come together when you see all 4 aim types. Now, you already saw all 4 aim types because you saw that video, but you haven't seen Billy and I talk about all 4 aim types because you're here now in the flesh. So when you see all 4 aim types, it's all going to come together. What you're going to discover is that, well, you'll see. I don't want to do module 7 just yet because I want to get through this one. But everybody, is this cool? Are we having fun? I got 3 minutes left before I let Greg go. But are we good? I loved your question. I just love the questions because they get us into these rabbit holes. You know, I love it. I love it. And I've been giving this module for 15 years and I'm done. Like I want my students next year to give it. You know what I mean? You know? So, all right. You're welcome. I love the questions. I love them. All right. So does pooling make sense? Well, that's up to you. It's causal. It's valid. To us causal inference people, it's valid. The place it makes the most sense to us is if you think about it, instead of from add med versus enhance, or add BMOD versus enhance, it's if you think about it through the lens of a tactic. When you think about it through those lens, well, yeah, this is the augment strategy. This is the intensify strategy. In other words, you could have done a randomized trial. Listen carefully. You could have done a 2-arm randomized trial that only recruited non-responders, and half of them got augmented to whatever they were on, and the other half got intensified to whatever treatment they were on. That's sort of like the underlying logic to why Billy and I and Susan and all this think pooling makes sense here. But ultimately, you have to buy that logic, right? That's your story. That was our story. I love it from a services delivery point of view. I love questions like this. Love them. Love them. Yeah. No, I'm going to give you your time. It's time, right, Ian? Yep. All right, let me go 1 minute and wrap up. 5 minutes? Okay, Greg. And then you can go over 5. Okay. I know the way Greg likes to give talks though. So there's limited slides and he talks his way through. So we can cut him off whenever no, I'm just kidding. All right. So the only difference here is that you're subsetting the data to non-responders. I don't even need to have that slide up there. All right, and and in the fake data, here's what it looked like. There was a difference of 0.79 on average school performance. So almost 1 GPA, if I'm thinking in terms of GPA. And it was significant. And we shouldn't be showing these p-values. All right. We did it. Any other questions? We actually made it on time, and I didn't think I would. Yay! Greg, we're not cutting into you. So anyone have any last-minute questions for me? I'm going to come back right after Greg. We're gonna do some more of this. But I think we leveled the playing field with things you already know. Are we good? All right. Billy, you're up, and Greg is up.